In this second video about correlation, we're going to look at cautions about correlation. What does correlation tell us and what does it not tell us? So the first thing is that correlation does not imply causation. So we're going to look at some sort of humorous examples of this. First of all, the age of America correlates very highly with murders by steam, hot vapors, and hot objects. If you look at the data here, there's the age of Miss America. Here are the various murders. The correlation is quite high. You can see a definite linear trend. But I know that we wouldn't say that the age of Miss America causes these deaths, nor would these deaths cause the age of Miss America. So there is no cause and effect here. Here's another one. The per capita cheese consumption in the United States correlates very highly with the number of people who died by becoming entangled in their bed sheets. Here's the correlation coefficient of 0.947. You can see a very strong linear trend. But once again, I don't know that that consuming cheese causes you to die by becoming tangled in your bed sheet. So once again, not a cause and effect relationship, but there is a correlation. Here's another one. Divorce rate in Maine correlates with per capita consumption of margarine in the U.S. So the more margarine people eat in the United States, the more divorces we have in Maine. Look at that strong correlation, 0.99. Almost every point on the line, but no cause and effect. People who drowned after falling out of a fishing boat correlates with marriage rate in Kentucky. So the more people get married in Kentucky, or the more people who drown, I guess, the more people who get married in Kentucky. And so interesting. I don't know which one causes the other, neither. If you want to see more of these funny correlations, Google spurious correlations. But the big idea here is just because something has a strong R value and makes a nice straight scatter plot doesn't mean one causes the other. Okay, next, correlation requires that both variables be quantitative. Okay, people will often use the word correlation kind of casually to just imply any sort of relationship, but technically it has to be calculated from z-scores of quantitative variables. So be careful about applying that word to anything other than quantitative variables. Correlation only measures the strength of a linear relationship between variables. Correlation does not describe curved relationships between variables. Okay, we're going to look at that using an applet. So let's take a look at that. Actually, I'm going to come back to that. We'll finish going through this list and then we'll look at that. A correlation of 0 does not mean that there is no relationship between the variables, just that there is no linear relationship. And likewise, a correlation of r close to 1 or 1 does not guarantee a linear relationship between two variables. Okay, so let's look at this applet here and see what this has to show us about these relationships. So let's look at number 3 first of all. Correlation only measures the strength of a linear relationship between two variables. Okay. So I'm going to draw a relationship that has a high correlation Okay, this is a high correlation. It is very close to 1, but this is clearly a curved relationship. So we can see that a high correlation or a correlation of positive or negative 1 does not guarantee that the relationship is linear. Let's look at another one. Notice this correlation is very close to 0. If I had made it perfectly symmetric, it would be exactly 0. So this is telling us that there is no linear relationship, but it doesn't mean that there's no relationship at all. Clearly there's a curved, looks kind of like a quadratic relationship. It's a little bit non-symmetric, but it's pretty close to a quadratic relationship, but just not a curved relationship. So let's go back and summarize in your notes here. Okay, so we have here a correlation close to 1 or negative 1 does not necessarily mean that the relationship is linear. This one is clearly curved. Here we have a correlation close to 0, and in this other example I made it even closer than the one I just did. There's no linear relationship between x and y, but there is clearly a quadratic relationship. Okay, the next thing I want to do is look at this little scatter plot right here. This should be similar to the one that's in your notes. It's probably slightly different. I want you to notice how strong this relationship is. You get 0.8579, fairly strong linear relationship. Now I'm going to add a point that will make it stronger, and I'm also going to add a point that will make it weaker. So if I go in line with the trend of the data and add a point that is very far away from the data, notice how much stronger. It went from 0.85 to 0.96. So adding a point that is in line with the rest of the data will strengthen the correlation. Now I'm going to add to remove this point, and I'm going to move it somewhere else. I'm going to put a point way down here. So try to think what change that would make in the correlation. Did you expect that much of a drastic change? What if I put it out here or down here? So I'm trying to do it. There we go. If I put it out here even more extreme, not only did I change the correlation to be close to 0, I actually made it negative. So we're showing this point alone changes a positive trend to a very weak negative trend. So you can see that if we look at the bottom here of our notes, let me clear this off here, correlation is not resistant to outliers. It is greatly affected by a few outline observations. So here are the two that we did. Adding this point greatly increases the correlation, but adding that point, I'm going to change this to this point because I want to say this specific point. This point greatly increases correlation, but adding this point changes the correlation from strong and positive to weak and negative. So, moral of the story here. Correlation alone is not a complete summary of two-variable data. Look at other stats, mean, standard deviation, etc. But most importantly, look at the graph. The graph together with the correlation tells you a great deal about the data.